Hey guys, I decided to make a self-steering scooter using reinforcement learning for my final project. Electric scooters are the future of micromobility, but it has issues such as being misplaced and causing injuries, both of which can be solved by developing autonomous scooters. The first step towards this is to develop a scooter that can steer itself to a location without falling down, which is exactly what I'll attempt to do in this project. There are three main ways of balancing a scooter: steering control, mass balancing, and control moment gyroscope. I choose to use steering control due to its low energy consumption, but it does require the scooter to be at a certain velocity. I created a simulation of the scooter in MuJoCo, a physical simulation framework. At each 1/30th of a second, the agent receives the following state: the angle and angular velocity of the scooter's tilt, as well as the current position and target position of the steering servo. The agent can choose to change the servo target position by 0.1, 0.01, 0, -0.01, or -0.1. The scooter is always in motion around 12 miles per hour. The first task is to simply keep itself balanced after starting with a random tilt. It receives a reward of 1 for every time step that is not falling. I used the PPO algorithm for training, and pretty soon the scooter learns to balance itself indefinitely. I thought I had an infinite loop in my code at first. I've also tried to use the DQN algorithm, but it wasn't performing quite as well as PPO. The second task is to navigate to a fixed goal after starting at a fixed location facing a random direction. The state additionally includes the assigned angle between the direction that the scooter is facing and the goal. Rewards are given as a combination of various factors. After a tedious training process, my little scooter can accomplish this task quite well, almost always able to reach the goal. I've also tried to make the action space continuous, that is, letting the scooter set the goal position of the steering servo directly between -0.5 and 0.5. But this produced a scooter that apparently thinks that it's a helicopter. As you can imagine, the same trained network can also navigate from a random starting location and direction to a random goal. It can also follow a series of goals to steer itself on a specific path, which is very useful in navigation. To make this task harder, I've also tried adding obstacles. But since the scooter steering joint has high friction, it doesn't seem to be too bothered by it. A lot more work is still needed to bring this into reality, but try not to freak out if you ever see this running around the streets in the near future.